Now we're going to configure our second middle router, the Valkyrie. And again, it's got traffic flowing in more than one direction. Look at its direct adjacencies. Okay, what are the networks it knows about? In this case, it knows about network 80, it knows about network 96, it also knows about network 60 here, or excuse me, 64. What it does not know about in this direction would be what? 48, 32, and 16. So we have to teach it about 48, 32, and 16, and it's going to send all that traffic to 65, right? To the IP of the router connected to its direct adjacency. Now the other traffic's got to go the opposite direction. Again, sure, it knows about, in this case, 64, and it knows about 80, and it knows about 96, but all the other networks from 112 to 176 have to be routed this way, and they're going to have to get sent to IP address 192.168.10.98. So let's go configure that and set that up. And again, first we'll look at the routing table and notice that there are three adjacencies. These are what it knows about, 80, 96, and 64. So why don't we start with the lowest network first that has to get routed to 192.168.10.65. And if the lowest network it knows about is 64, then we have to kind of work our way backwards. So 48, 32, and 16, we need to teach it how to route traffic to those networks. And the way to do that, we would again go to global and use IP route and 192.168.10, which is our network address, and then the networks we want to teach it, we'll start with the lowest one, or why don't we start with the highest and we'll work our way down to the lowest. I'm not trying to figure out what's more logical, or hopefully what's more easy for you guys to follow. I try to think of that instead of just doing it my own way, but oh well. Maybe if we work our way backwards, you can kind of see the progression, right? So we'll do 48, 32, and 16. Maybe that's more logical than starting at 16 and working. Maybe we're just overthinking. Okay, why don't we just do it? All right, 192.168 and 10, and the IP address is going to be 65, right? 1065. That's where we want to send our traffic. And then we just need to teach it the next two networks. So working our way backwards, the next lowest would be 32, and the next lowest would be 16. And we've taken care of all of our lower subnets. So all of our traffic moving this way, all of our lower subnets. Now we need to take care of our higher subnets, which is our traffic moving this way. And let's see what we have to teach it. So once again, it knows about 64, and it knows about 80, and it knows about 96. And now it knows about 48 and 32 and 16, but the higher subnets, we have to teach it how to route traffic or how to reach those. And that would be, again, we'll start with 112, but that's going to be on its serial connection here on network 96, right? It's 97. Well, the nearest adjacency to get it to the higher subnets is going to be on the Datalist here, and that's 98, 97, 98. So we have to send all those packets, all that traffic to 192.168.10.98. And we can do the same for all of the higher subnets moving through. So 112 and 128. And let's do 144. And let's do 160. And let's do 176. Okay. And I'm going to Control Z down to privilege mode, then do a show IP route to once again look at my routing table. And again, notice my traffic's flowing now in both directions, and you just want to double check and make sure things are as they should be. You can also use show run and look at some of your static routing information that you've input. But everything looks good there. So I'm going to go ahead and save it and copy and start. And we just have two routers left to go. We're going to configure our next middle router, which would be the Datalist. And once again, what are its direct adjacencies? What networks does it know about? The 96 subnet, the 112 subnet, and the 128 subnet. So we don't really have to worry about teaching it those, but all the others will have to teach it. So let me go ahead and go to privilege mode, and we'll take a look at our routing table with no entries yet. I do a show IP route. Notice there's three adjacencies or connections, so 96, 112, and 128. No need to teach it any of those things, but we do need to teach it how to send traffic two networks not directly connected to it. Once again, why don't we start with the lower? And for the lower traffic, those packets, those datagrams, where would they be routed to? Well, if we're going to go from 16 all the way to our highest network here, it would be on this 96 network. And to get it there, the adjacency, the IP address of the router, closest router connected to it, the adjacency that's in the right direction would be what? 192.168.10.97, right? And this is 10.98. So all that traffic we want to send over to the Valkyrie, which is on this interface, 192.168.10.97. So we need to route it. So again, I'll go to global configuration mode. Again, I'll use the command IP route 192.168.10, our network. And then why don't we start, again, we'll just start at the highest address and work our way down to the lowest to route to that direction. So for one that's not an adjacency, it's going to be 80, right? 80's, if we're working our way backwards, subtract 16 from 96, 80 all the way down to 16 is the direction we're going to go. And our normal subnet mask for subnetting on 4 bits and where to route it to, the actual IP address, 192.168.10. And remember what it was 97, okay, 97 there. And all of our traffic that's going lower is going to go in the same direction. So once again, I'm just going to keep using that static IP there. And so 80, let's do subnet 64, based on a multiple of 16 or block of 16. Let's do subnet 48. Let's do subnet 32. And let's do finally the subnet 16, our very first subnet. And that way all the lower traffic is traveling in the right direction. Now we need to do the higher traffic, traveling to the higher subnets that the Datalist doesn't know about, that doesn't have an adjacency to, and that's going to be sent to the Artemis, right, to this interface. So the last network, the highest that it knows about via direct connection or adjacency is the 128 subnet right here. After that, when it gets to the 160 and when it gets over here to the 144, it needs to be taught how to, where to send those packets or how to route them. And where's it going to send them to? Anything going higher to the higher subnets needs to be sent in this direction, right, to 192.168.10.130, which is not the direct interface, but the closest adjacency of the router on that same network that's that's moving the packets in the right direction. So for us, it's 192.168.10.130. So to do that, we'll go ahead and put the address in there, and then now let's work our way up for the addresses that we need to teach the Datalist. And so it's going to be 144. Needs to know how to route traffic there, and then it's going to be 160, moving up by 16. And then 176, our last subnet. Okay. And then again, I'm going to Control Z down to privilege mode. Take a gander at our routing table. And things look hunky-dory. And you could also do a show run if you so chose. And by the way, don't forget while we're here, the show controllers command. And remember that will give you the DTE or DCE status of each of your connections, and you'll need that. Remember you've got to set the clock rate on the right connections and the bandwidth. So depending on if it's DC, you need to set the clock rate. If it's DT, you don't have to worry about it. Just remember that. So let's do a copy run start, and we just have one router left to go. Okay, our last router to configure is going to be the Artemis, right? And then that'll be all of them. We've got the Galactica, the Pegasus, the Valkyrie, the Datalist, the Artemis, and the Persephone. We don't have to really worry. Again, we're not doing VLANs in this example, so don't worry about the Copernicus, Kepler, Galileo, Newton, Tesla, or Hawking. But on the Artemis, we once again want to look at, let me go to global. Actually, before I do that, I'm going to privilege mode here. Okay, we have three, adjacencies or direct connections, and again, this is what the Artemis knows about. Let me drag this down here. So hyperterminal's down there, and again, you can see that. What does it know about? Well, it knows about the 160 network, it knows about the 128 network, and what else does it know about? The 144 network. So we don't have to teach it anything there. But we do have to teach it how to find everything else. So, in other words, like 176, the subnet over here, doesn't know how to find the 176 subnet. So, and that's the only thing going in that direction. So I'm going to do that one first, because everything else is going in the other direction, and that'll be a piece of cake once we iron out where to send it, what IP address to send it to. So my command would be IP route 192.168.10, and the subnet, which would be 176, the mask. And then where do I send it to? Well, 192.168.10, and what's the IP address? Well, it's the closest router on the adjacency of that network connected to that router. So on the Persephone, it's going to be 192.168.10.162, because that was 161, right? So 162.162. And then everything else, that routes any traffic this way that the Artemis doesn't know about, that doesn't have a direct adjacency to. The rest of the traffic has to go in the opposite direction. So that'll be easy. Once we, all the traffic going here to the lower subnets all the way down to 16 needs to be sent where? To the closest adjacency of the router in the right direction, which would be the Datalist. And this is 130, so it's going to be what? 192.168.10.129 to this interface IP of the next router. And all that traffic, I'm moving the cursor here, but all that traffic has to be routed that way. So in order to do that, once again, we'll use our IP route command. But instead of 162, where do we want to send it to? 129 on the Datalist. Okay, so 129. And of course, we don't want to route 176. That's going in the opposite direction. But we want to work our way down from here on out, all the way down. So again, the lowest network it knows about as an adjacency is 128. So subtract 16, and working your way down from multiples of 16 or a block of 16, you can figure out all the other networks you have to teach it. So the first one would be what? 112. I'll just hit the up arrow, and I can keep using the 129 all the way down now. 112 and then 96. Oops, I said 196, and that's not what I want to do. But this is a good opportunity to show you the no IP route command. It's the only problem with using the up arrow. Sometimes you get carried away. But let me do, instead of 1, let me do 96. There. And that's going out 129. Okay. And then the next one, again, subtract your 16 would give you 80. So the next block value, the next network would be 80. Make sure I don't leave that extra one there. Then the next network would be 64. And then the next network would be 48. And then the next network would be 32. And then the last network would be 16 in our static routing table. And again, on a small network like this, where you only have 11 subnets, static routing is actually, I think, your better choice, because it has the lowest administrative distance. It's the most efficient, and as you can see, it doesn't really take you that long to set it up. It's not really that much trouble. Granted, OSPF or RIP or would be a lot faster setting this up, and EIGRP would be great too, but they still don't have the lowest administrative distance of them all. EIGRP is 90, so 90 versus 1. Hey, think about it. You have like no broadcast traffic, you have no updating traffic, no topology table, nothing. It's there, it's instant, bam, it's in the router. So for a small network that's not too complicated, static routing is a great choice. It's a great option, and it's not really that difficult to set up. Now, when we get to larger, more complex networks, yeah, we're going to have to use dynamic protocol. And if you got all Cisco equipment, hopefully it'll be EIGRP. If not, then maybe OSPF is a good choice. But let's go ahead and look at our routing table. Control Z under privilege mode and show IP route. And look at our traffic. Make sure it's being routed properly in the right direction. So 162 and 129 respectively, and then there are all of our subnets based on our mask value of 240 and the last byte or octet and 4 bits. Looks good. Copy, run, start. Woohoo! And we are good to go. And now there's just a task of testing all this out. And you can test it out on the router first. And if I had any technical issues, that's where I would actually start with diagnostics. I'd hop on the router because my gateways could be wrong. There's a lot of things that could be wrong if I just started testing up here. So if I had any issues, that's what I would do. I'd go to the router, make sure I could ping a direct adjacency. A lot of times you may have forgotten to bring up a command when there's shutdown, or you might not have configured the clock rate on a DCE end or something like that. And you could easily figure that out just by testing connectivity from the router itself. You can use the ping command and trace route there. But I'm just gonna, to save time on the video, I'm gonna jump on up over here and we'll hop on the GAIS. And let's just see what we can ping. And let me move this over here. And we'll, of course, we should be able to get anybody in his local subnet, right? Shouldn't have any problem there because that doesn't even require routing. He's in the same broadcast domain as Adama and the switch Copernicus and the gateway on the Galactica 17. So if we tried to reach that 192.168, 10, let's try the Adama, which is 19. And they're in the same broadcast domain, so no routing involved. If I couldn't reach that, I know something's really wrong. And there's no IP on the Copernicus, but let's try the gateway, right, which is the interface on the router, the Galactica, no problem there. Okay, so the routing is good on the first subnet. And if I could reach that far, I should be able to reach an adjacency, a direct adjacency on the router, so like 1033 on the Galactica should be accessible. But from here on out, if I don't have static entries or dynamic entries set up correctly in my routing tables, it's not going to know how to route the datagrams or packets to and then return the echo replies from those addresses unless the routing tables know how to send them back. And it's not just the entries in the Galactica, but this next ping from here on out is going to involve at least 2 routers, if not more. That was all just involving 1 router, but think about it. It's not just that the Galactica has to know where to send the packets to get them to the Pegasus, to the next network, but the Pegasus also has to know how to send the packets back, the echo replies, to the direction of network 16. If I had bad entries in either one of these routers, then I'm not going to get echo replies using the ICMP ping command. So let's keep going from there. That was 33. Now we'll try 34. Alright, so we're getting from subnet 16 to subnet 32. And then what's the next one? We hop on over here on the Pegasus, and then from 32 we get to the 48 subnet. So let's see if we can't reach some of those addresses. We'll try the gateway first, which is 49. Looks good. And then let's try the Sagan, the Carl Sagan, and the Charles Babbage. So that's what, 50 and 51. As long as our gateway is configured properly on those hosts, we should be able to get our echo replies, and there they are. Okay, so we've routed so far successfully from 16 to 32 to 48. And then let's try the next network. Remember, the next subnet was 64. So we'll try 65 and 66. And should be able to get 65. That's just an adjacency on the same router, or an interface on that same router. But again, to get 66, we'll have to have the routing path configured properly between these 3 routers, the Galactica, the Pegasus, and the Valkyrie. So to take a look at that, 65, let's do 66 now. Okay, and now we reached the 66 there. Now let's go over here, and the gateway, the next network is 80. So the gateway is 81, and then Cameron and the T1000 Terminator, they're 82 and 83. So let's see if we can't get the gateway in those IPs. So gateway 81 and 2, beautiful deadly Cameron, and 83, which is the T1000. Looks good. Okay. So after that, what's our next network is going to be the 96 subnet. And our valid IPs are what, 97 and 98 there. So let's see if we can reach the next one. 97, looks good. And the connection to the next router, 98, looks good. So far we've tested routing all the way from here, all these networks, all the way down to here, down to the Datalist. That's where we've made it to so far. And all the way to subnet 96, which is the connecting subnet between the Valkyrie and the Datalist, these 2 routers. So now let's try other adjacencies and networks off of that router. So from the 96, let's jump to the 112, and we'll see if we can hit the gateway, which is 113. Should be able to, just an adjacency there. Okay, good. Now let's try some hosts, and unless the gateways are configured wrong on Kirk and Spock, we should also be able to route to them. So let's do 114 and 115. Everything looks hunky-dory. And now we're ready to try the jump to the next router. So let's try network 128. So we'll do 129. Should have no problem with the direct adjacency. And then when we try to reach the Artemis, we'll have to have routing tables set up right, on these on up to 5 routers. So 129, 130. Let's try that. I guess I'm really dragging this out, but I'm just trying to put it under the microscope and show you how it works. Okay, so everything's good there. And then we've tested our networking all the way over here. So now why don't we try in this case, the 144 network and the 160 network. We'll do that. So what is our gateway? 145 and then 146 and 147. Looks good. But that's just an adjacency. Now what about the gateway? So 46 and 47. And looks good there. And then what's our next network? In this case 160, so 161 and 162 respectively. 161, just a direct adjacency, and then on that same network 162. Now we got all 6 routers routing back and forth, and then our last network is what? The 176 subnet. So gateway is 177, and then the Da Vinci and the Michio Kaku are going to be 178, 179. So let's see if we can't reach those guys as well. So on network 176, we'll try to get access to our gateway 177. Just another adjacency, no issue there, but our gateways better be set up right on the Da Vinci and the Michio Kaku, or they won't return the echo replies properly through the gateway of the router. So let's try that, 178. And finally 179. Good old Michio Kaku. Alright, so everything's good. Everything, our static routing didn't really take us that long. And this is the most efficient, fastest, absolute maximum performance you can get when you implement static routing. If you're willing to put forth the effort, just a little bit of configuration effort. Yes, it's a little bit more work than dynamic routing protocols, but man, you get a much cleaner, more efficient network. But the next tutorial we'll look at doing larger networks. The only thing is, again, like I said, it's not really practical for larger networks. Imagine if you had 50 or 100 subnets. Okay, then static routing gets to be cumbersome, and at that point maybe you're just going to start using EIGRP, or maybe you're on a network where things change rapidly. You're constantly moving things around, adding new subnets, removing. If that's the case, again, maybe static routing is a little bit more work than you want to put yourself into. And if that's the case, dynamic protocols. So the next thing we'll implement OSPF and then maybe EIGRP on this network.